Hello students, welcome back. Let us start with a new chapter, that's chapter number 13 of your textbooks, surface areas and volumes. And the topics to be covered are the introduction, of course. Then we have surface area of different objects. So those would be cuboid and cube, then right circular cylinder, right circular cone and surface area of a sphere. Then see, we are learning about surface area and volume. So we are covering the surface areas over here from this section to this section, and then we will take a look at the volumes of different objects, that would be cuboid, cylinder, right circular cone, volume of sphere, and finally we will take a look at the summary of all the topics that have been covered throughout the chapters. So let's start with the introduction. So before I start with the introduction here, let's get back to the topics to be covered. So if you notice these terms, cuboid, cube, right circular cylinder, right circular cone, sphere, then again the same thing, right? What do you notice about these terms? That they are all 3D objects. 3D objects are objects like this chalk. It just doesn't have this front side, but it has another side here and a back side as well. So it has three axes, that is the x-axis, y-axis and the z-axis. So coming to the difference between what is area and what is surface area. So area is something that is applicable only to two-dimensional objects. Two-dimensional or 2D objects. So I can say that if I stick a paper on this board, if suppose this is a paper, it is two-dimensional. Why? Because it has an x-axis and a y-axis. But if I take into consideration a cube, if you do not know what's a cube, I hope you remember playing with a Rubik's cube, right? Made of different colors. It is somewhat like this. So here if you notice, it has three axes. One is this axis, one is this axis here, and one is this axis. So this one is the x-axis, this is the y-axis and this is the z-axis, and this is the origin. The origin is here. So for example, if I take this duster into consideration, if I just take this front surface, it's two-dimensional. But no, it's not really two-dimensional, because look at this. This is a three-dimensional object which you cannot really draw on paper all the time, because it will have a z-axis. And so surface area is applicable for three-dimensional objects or 3D objects. So now when we are talking about area, let's say I have this paper over here, or maybe a circle drawn on the board. So maybe this is a bangle out here. So what is the area? The area is the amount of space enclosed within the edges or boundaries or the perimeter. So the area of this paper is this entire space that is covered within the boundaries of this paper. Similarly, the area would be this entire space covered within the circular region or within the circumference. So it was very easy when I mentioned about area over here. How about a three-dimensional object? This was 2D. How about the surface area? So instead of paper, I am going to take a duster this time. If you see, it has this face. So the total surface area is going to be the sum of this area plus this area plus this area at the top, at the bottom and the two sides. So 6 faces. So the total surface area is going to be the sum of all the areas of this duster. Sum of areas of all faces of this duster. So it was very simple when I mentioned to you about the duster, because here you have edges and boundaries to describe it. But what about a sphere? A sphere is a round spherical object just like our earth or this small ball. So what would be the total surface area? You cannot really see any boundary out here. So the entire area, the entire space that is covered here on all the sides, no, not even a single dot is missed, which is going to be your total surface area or the surface area of the sphere. So we are not just going to learn about surface areas of cubes and spheres, but also a cone and cylinder. So let's again, if I take an example of a cylinder. take a look at this cup. The total surface area is going to be the sum of this entire area plus this area. So if I cut this over here, right, let me draw a line. So if I draw a line over here and I cut this region and I remove this base, then the total area, this cup will open up, right? So the entire area would be this curved surface area plus this area. I won't be taking into consideration this area over here because it does not have a lid. Had it had a lid, then I would have got the total surface area including the lid as well. So now if you notice, this is a hollow cylinder. Not just this, but if I take for example, say a cuboid as well. It is again hollow. So if you notice, it has two kind of areas. So what are the two areas that we have? Just one moment. So what are the two areas that we have? We have the exterior area, that is the area covered by the exterior region, and the interior area, right? So the interior area would be the sum of all these sides plus the base inside. Similarly, for this tray out here, which is in the form of a cuboid but without a lid, our exterior surface area is going to be the sum of all these four faces and the bottom, and the interior area would be the sum of all these areas and the bottom inside, right? So this was about your surface area. Also, the unit of measurement for area and surface area, there's one thing in common, is that it is always going to be unit square. Area and surface area are always measured in unit square. Unit square or square units. So unit could take the place of millimeters, centimeters, meters, kilometers, miles, and so on. So you could say centimeter square or square centimeters, or meter squares or square meters, and so on. So this was about the introduction to the difference between area and surface area. So why are we exactly learning about surface area now? There are many applications wherein this concept will come handy, but the most important aspect is that in future when you are planning to buy a house or get the walls of your house painted, then it is very important that you know the surface area, because that is how you are going to calculate the see, usually what happens is you are given the cost at the rate of per square meters, whether it's for painting or for purchasing land. So you will have to calculate the amount with the entire total surface area, and you will get to understand how much you are actually supposed to pay. For example, if I have 4 walls out here, one is this wall. Take a look at this entire wall outside here, right? This is the interior region of your house. Then you have this wall here, then you have this wall here, and one is in the front. So if you need to find the cost of painting the wall, then you can easily find the area of the wall, total surface area of the wall, multiply it with the cost that, for example, if it is rupees 10 per square meter, then, and if the area of your walls is 400 square meters, then the total cost would be simply 400 into 10, which would be 4,000. And the another example that I can give you is, let's say you're going out on a tour with your friends, and you have to, it's a very remote area wherein you need to stay within tents. So for the tent also, how much cloth will be required to construct the tent, that you will be able to decide only if you know what is the total surface area. Okay, so this was about surface area. Now what about volume? So I remember that when I was in school, my teacher explained to me what is volume in a very simple way, that she said that, for example, I'll give you this cup now. The amount of water, so liquid or solid or gas that can be filled into this hollow space is known as the volume. So if I have a cuboid again, so the amount of space that can be filled inside this cuboid, amount of water or air or gas that can be filled into this entire inside region within the boundaries of these walls and the base is known as the volume. So why are we learning about volumes? I'll give you a very crucial example and I'll give you a very simple example. So a crucial one and a simple example. So the crucial example would be that of medicine and simple would be that for a bucket. So you might be wondering what is the relationship between these two examples. The relationship is nothing but volume. Because in this case the volume is not really important, but coming to medicines, it's really important. For example, your prescriptions, whenever if you must have fallen sick, the doctor must have prescribed you certain medicines. So if it was specially a liquid medicine, you were suggested to take it specifically as 2.5 ml or 5 ml or 7 ml and so on, because an extra overdose could lead to a lot of side effects. And similarly for a bucket. So now you could decide whether how much room is there in your bathroom. You could go for a 10-liter bucket or a 20-liter bucket and so on, and depending on your needs also. So this is a very simple example. You could alternate between these two, but in the case of medicines, it is very important to consume medicines in prescribed quantity only. Right? So this was about the introduction about surface areas, volumes, areas, and why are we learning this entire chapter. We'll take a look at the first topic, that is the surface area of cuboid and a cube, in the forthcoming lecture. Thank you.
Hope this video increased your knowledge. For more such videos and a completely free educational content, log on to www.epathshala.org or visit our ePathshala YouTube channel. We have each and every question solved for maths, physics, chemistry and biology. So subscribe our channel, share with your friends, like our Facebook page and follow our Twitter handle for regular updates and important educational tips, and also win ePathshala goodies. So what are you waiting for? Subscribe this channel and enjoy the freedom of education.